Take a moment and read through problem number 5 in the related rates packet. I hope you can sort of picture what's going on here. We've got sand falling, and as it falls, it sort of builds up a cone of sand. And the height is always 3/8 of the diameter. Okay, all that stuff is good. Let's go and start setting this up. First of all, you need the formula for the volume of a cone. I bet you can find that on the front of your packet. Go get that and write down that formula. Volume of a cone is going to be 1/3 pi r squared times the height. Let's see. Sand is falling at a rate of 30 cubic feet per minute onto this pile. What is that? Is that dV dt, rate of change of the volume, dr dt, rate of change of the radius, or dh dt, rate of change of the height? Hint, look at the units. Should be the rate of change of the volume. We are directly increasing the amount of sand there, which is changing our volume. So I know that dV dt, the rate of change of the volume, is 30 cubic feet per minute. There's going to be more that I do in part 1, but for right now, let me move on to do part 2. Actually, how about you take a moment, you go do part 2. We're looking to find d what dt. How fast is the height changing? That means dh dt. When h equals 12 feet. Well, here's the problem. I have too many variables over here. I have no information right now about dr dt or a particular radius or any of those things. So I can't do what I did in number 4 where I used my product rule and got a dr dt, a dt, because I don't know anything about dr dt. But there's a piece of information we have not yet used. The height of the pile is always 3/8 of the diameter. Let me write that down because that's something that's always true. The height of the pile is always 3/8 of the diameter. Oh good, I just introduced a new variable to this. Let's not really use d. d, the diameter, is the same as saying what? d is the same as saying twice the radius. So how about I do that? h equals 3/8 times 2r, or h equals 6/8 r, or h equals 3/4 r. The height is always 3/4 of the radius. And actually, since the height is always 3/4 of the radius, I could plug this in at this point. Although I've got to be careful. There are two ways I could do this. I could plug in h and get an equation that just has r's in it. Or I could take this thing, I could solve it for r, get r equals something with h's in it, plug that in, and then just get a formula with h's in it. Since I want to find dh dt, and I have information about an h, I want my volume formula to have h's in it rather than to have r's in it. So what I'm going to do is I'm going to solve this thing for r. I'm going to say r equals 4/3 h, and then I'm going to go and I'm going to plug that in. This is still all part of part 1. I'm just trying to make a formula that will always be true that I can then find the derivative of. v equals 1/3 pi times 4/3 h. I'm going to square that and multiply it by another h. You know what? How about you take a moment, just kind of work through the algebra to clean that up. Let's see, so I think I can say v equals 16 pi over 27, just to put the whole constant out front, h cubed. And this is the formula I'm really going to use for my volume. Well, let's go. Part 3, I'd like you to go create the formula for dV dt. dV dt equals, take a moment, do it, realizing that this is just a constant out front, so this actually shouldn't be horrible. Go create your formula. So I'm leaving that constant out front, 16 pi over 27. Derivative of h cubed is 3h squared dh dt. Might as well clean this up a little bit. Actually, I can do 3 over 27 and just turn that into over 9. dv dt equals 16 pi over 9 h squared dh dt. And I suppose at this point we should probably also plug in our 30 for dv dt and get a final formula in part 3 of 30 equals 16 pi over 9 h squared dh dt. I'd like you to go through part 4, plug in your specific height, that height of 12 feet, and solve for dh dt. Again, let's give exact answers and let's put units on it. See if you can get your dh dt. Let's see, 16 times 144. I might as well do 16 times 144 divided by 9 just to simplify this. I can say this is 30 equals 256 pi dh dt. Divide, we're going to get dh dt equals 30 over 256 pi. Make sure that pi is in the denominator. I know I can simplify the 30 and the 256. That'll become 15 over 128 pi. And the units of the height divided by the units of the time. The height is going to be in feet, and the time is going to be in minutes. And that's what we should get for our derivative.